Here's the big question. Is the Earth shrinking? Like, are we all slowly getting squashed together, or is it one of those weird science myths? Well, as it turns out, the Earth is going through some very interesting changes, and depending on how you look at it, the answer is kind of. But don't panic. You're not about to wake up one morning and find yourself 2 inches shorter because the Earth decided to pull in on itself, like a deflating balloon. However, there are a few processes at play that make this a surprisingly complex question. So let's break it down. Let's start with something that sounds dramatic. Earth is literally losing part of itself to space. Right now, our planet is shredding tiny amounts of gas, mostly hydrogen and helium, out into the void. This happens through a process called atmospheric escape, and there are a few different ways it works. Jeans escape? This is basically when super light gas molecules get enough energy to escape Earth's gravity altogether. Since hydrogen and helium are really light, they're the ones that go first. There is also solar wind stripping. This is when the sun blasts the Earth with charged particles, and sometimes they have enough energy to rip away parts of our atmosphere. This is actually what happened to Mars. Without a strong magnetic field to protect it, the planet lost most of its atmosphere, turning into the dry, dusty wasteland it is today. And finally, photochemical escape. This one's all about sunlight breaking apart molecules in the upper atmosphere, making some atoms fast enough to drift away into space. This all sounds like a big deal, right? Well, not really. Earth only loses a few kilograms of hydrogen per second, which compared to the entire atmosphere is barely a drop in the ocean. So while our planet is technically shedding some mass, it's nowhere near enough to cause any noticeable shrinking. Now, let's move on to something a little more solid, the Earth's core. The planet started off as a molten ball of hellfire, but over the past 4.5 billion years, it's been slowly cooling down, and as it cools, it contracts slightly. The inner core is mostly made up of iron and nickel, and is actually growing because the outer liquid core is slowly solidifying. Scientists estimate that the inner core expands by about 1 millimeter per year. That might sound like nothing, but over billions of years, it starts to add up. A shrinking core could, in theory, cause the entire planet to contract very slightly. But again, this is happening at such a slow rate that you would need millions of years to even notice a tiny difference. Now, compare that to Mercury. Mercury's core has been cooling so fast that the planet actually shrank by several kilometers, leaving behind massive cliffs called scarps. But Earth's tectonic activity stops this from happening here. Our planet constantly recycles itself, preventing large-scale shrinkage. So while Earth's insides might be changing, it's not enough to say the whole planet is shrinking in any way that matters to us. Here's where things get really interesting. The surface of the Earth is constantly shifting, thanks to plate tectonics. You've got new crust being formed at the mid-ocean ridges, and old crust being destroyed at subduction zones. So if land is constantly disappearing into the mantle, doesn't that mean the Earth is slowly shrinking? Well, no. Because for every bit of land that gets pulled down into the Earth, new land is being created elsewhere. It's basically a giant recycling system. Over millions of years, Earth's landmasses have dramatically changed shape. Entire continents have smashed together and broken apart. But in terms of total planetary size, not much has changed. There is a fringe theory called the expanding Earth hypothesis, which suggests the planet used to be much smaller and has been growing over time. But modern science has pretty much crushed this idea. There's no solid evidence to suggest Earth's radius has changed significantly in the past few 100 million years. Meanwhile, other planets and moons don't have active tectonics, like our moon, which has shrunk slightly, forming cracks and ridges as its interior cooled. But Earth, being the overachiever it is, keeps itself in check with constant movement. And here's the biggest plot twist. If anything, the Earth is actually getting bigger. How? Space dust. Every single day, Earth is bombarded with tiny bits of dust, meteoroids, and space debris. This isn't just a few specks here and there. Scientists estimate we gain about 40,000 tons of cosmic material every year. Over billions of years, that starts to add up. Sure, it's a tiny fraction of Earth's total mass, but it's way more than what we are losing from atmospheric escape. And, fun fact, biological growth also plays a tiny role. Life converts sunlight into energy, and while it doesn't add much in terms of mass, the Earth's biosphere does technically store some extra energy over time. So while people worry about the planet running out of resources, the bigger picture is that Earth is actually gaining stuff from our universe. It's kind of poetic, right? So, is the Earth actually shrinking? No. To give you the short answer, not really. The minor contraction from core cooling is way too small to make a difference. Tectonic activity balances itself out. Atmospheric loss is negligible. And on top of all of that, we're actually gaining mass from space dust. If anything, Earth is slowly getting heavier rather than smaller. So unless you were hoping to use planetary shrinkage as an excuse to blame gravity for your weight gain, sorry, but science says you're out of luck. But hey, now you can sleep easy, knowing that you won't get squished into a planetary pancake anytime soon.